try and see if this is working. I have no idea how to know. Oh, gone out, shut the door, come back. Oh, it's so weird. I can see myself in the past. Hello? Can you hear me? Is it working? How do I find out? Hello? Is the sound on? I see you. Hi. Is the sound on? Can you hear me? Maybe I should. Muted. Unmute. Can you hear me? Is it working? Yay. Okay, hi everyone. I'm seeing lots of people. Hi, hello. I'm going to say something. Hello. Yay. This is so fun. There's like chat. Oh no, hang on. Can you hear me? Is that an echo? Okay, so I'm going to carry on. I'm going to mute myself because otherwise I hear myself back in the future. So, hi everyone. Sorry, I'm just trying to get used to this because I've never done it before. So, my name is Becca Rose, and I am a digital artist, maker, educator based in Bristol. And Jocelyn from Collabs kindly invited me to do a session on E-Textiles because I do a lot of making with E-Textiles. And yeah, so I'm going to share some techniques, some ideas. What else? I've got a list here, so I'm going to refer to my list. We're going to make a circuit from scratch. So I'll show you how things work, the techniques, how they kind of work as a system. I have a book and I'm going to read a little passage from it. And that's about it. I will explain as I go, so please ask questions. And yeah, it's really great to be here. Oh look, my mom is here. Hi mum. That's so funny. My mum lives in France, so I don't get to see her very often. So it's nice to be here in this digital space. But yeah, thank you Collab for having me, and hopefully this is really useful. And if you're not joining live and you can see this later, hopefully some of these techniques you can use in your practice in some way. So where should I start? Yeah, so maybe I'll just start by speaking a little bit about being a creative technologist, because the Collab is kind of this intersection between creative practice and kind of technical practices. And so what I'm going to be showing today, electronic textiles, sewable circuits, E-Textiles, is this kind of intersection between kind of textile practice, knitting, sewing, lots of kind of handcraft skills, and more technical practices, such as making circuits or other objects. And yeah, and so I'm an artist and I'm coming from that perspective. So what I'm going to talk about today is maybe a little bit more about some creative ways that you can use materials. And I'm just basically giving myself a disclaimer because I probably say things that aren't 100% technically correct, and I'd be very happy for you to share feedback in the comments about some better, more technical ways of speaking about things. But I'm coming from a textile practice background, so that's the way I'm going to speak about things today. And yeah, what I was gonna do is I have another camera view, so I'm going to kind of talk mostly with my hands and with materials, so you can go along, but I'll kind of maybe switch between this view, you can see me in my kitchen, and a kind of close-up of my beautifully manicured nails. And yeah, maybe I'll just get started because it looks like a few people are here already. Yeah, so let's just move into this other view. 1 second. Let's have a look. Is it gonna work? Yes, there we are. Okay, so here is the other view. Let's just straighten it out a bit so you can get as much. Yes, there we go. Here. So here is my little making space here, there. So yeah, I'm going to start with talking about some materials that we use in electronic textiles, but maybe before that, I will just show you a circuit that I'm going to show you how to make in a bit. Here it is. And I said in the link, if you've read the information, I've said that I've been exploring some different materials from around the house that we might be able to make sensors with. And so this little circuit here, I found these spoons, these tiny little cute spoons in a cupboard, and they make a great sensor because they're conductive and they make a little switch. And so what I'm going to do today, as well as kind of show you some other materials, is just show you how to make, let's see a bit of a close-up of that, a little circuit. It's got a battery in it, it's got a light, like a little LED light. It has, someone just said beautiful nails, thank you, Gisela. It has these lovely stitched circuitry using conductive thread, which is a kind of nylon-based thread interwoven with copper so that you can use it to make some really beautiful circuits. This is a chain stitch here. And then it's got this, as you can see, kind of see the light. The battery's a bit dead because I've been using this for a couple of days now, or since yesterday, sorry. But yeah, you can kind of see the light flicker on and off when I touch these two spoons, which are kind of makeshift light sensor. And if I had more space, I could kind of jingle this around and show you how you can wear it kind of on your head if you imagine the lights going on and off. But I don't think you can really get it all in the frame, so never mind. But you can just kind of imagine the kind of movement that these spoons jingling around would sense and create, turning the lights on and off. So that's kind of where we're aiming. And to do that, we will need some conductive threads to make the kind of the traces, the circuitry. And I have a few different conductive threads. The one I'm using mostly. So in E-Textiles, instead of using wires, we use conductive threads. And this one here is the one that I really like. Has lots of problems too. It's not the best material, but it's really great because it's very conductive. So you can sew really long circuits and it still works. I've got a little box of these, which I've kind of put onto cardboard. So this is what I'm going to use. And I'll just get some of this out and just show you a few different materials that we have. So this is the thread, snip that there. And it's hard to see because it's very thin. Whoop, there we go. There it is. It's really beautiful. The colour is so nice, and it's I think this is a 5-ply. Actually, it says so on the box. What does it say? 7. So it's 7 different. Oh, where are we? 7 different very fine copper threads woven, plied, kind of twisted around this nylon core. And this is the kind of basis of E-Textiles, is using threads instead of wires or kind of harder materials. And the nice thing about these is they're pliable. You can sew them into any shape you like. You don't have to have straight lines. You can have curves, and you can do lots of lovely things with them, like you can make lace, you can knit, you can do crochet. All sorts of different techniques that I'll show you some of in a while. So that's one material. I have to say my neighbour's doing some drumming, so you might be able to hear that. Maybe it's enjoyable, hopefully. Okay, so this material here is it's made by a company called Grimm, and they're based in Germany. And the reason I use this because I really like the material, but it's actually quite hard to get hold of. The way I got hold of it was through working with a collaborator, Annie Lywood, who bought a kilo, because a kilo is the minimum that you can buy. And so I kind of have just shared a little bit of her stock. And if you are interested in getting hold of some of this, one way of getting hold of it is by sharing it with other people, but also one top tip that I found out is that you can get multiple spools made up. So, for example, there's 3 of you that wants a kilo. You can ask them to spool it into three reels like this, and then you don't have to deal with like splitting it up like I've done onto these kind of, where is it, tiny cardboard spools. These cardboard spools are quite good for sharing though. I often take them to workshops with me, and then if someone's really keen, you can kind of just give them a small amount, and then that helps people get started, not having to buy a kilo of the material, because that can be expensive. So before I use any of these, I thought I'd show you another. This is another thread. This is one that's a lot easier to get hold of. I'm just going to cut a bit off here. And here we go. Where are we? Yeah, so this is a slightly darker material. It's made out of steel, not copper. And has it got a core, actually? I'm not sure. I think this one is a slightly different setup. So the one that I showed you at the beginning, actually I'm going to scratch it away and show you if I can. Scratch it away, yeah. Just do a bit of scratch work. So this one here, yeah, can you see in the middle, it's got like a nylon core, and the copper is wound around that nylon core, whereas this steel thread is actually got microfibers combined with steel in the actual material. So it's not got a kind of core, which means it's a much nicer thread to sew with. It's less brittle, it's really soft. But it also means that it is not so good for like longer distances. So if you're going to have a really, really long circuit, you would have a lot more resistance, because this, and you wouldn't get, so if you had a light on one end of the circuit, it wouldn't be as bright as if you use this lovely copper stuff. So that's the reason why I use the copper, because it's has less resistance in it. But they're both nice to use. What else? Oh yeah, so I'll show you another material, and then we're going to look at the kind of resistance to what I was talking about. So this is the yarn, the conductive yarn. Just cut that off there. And I'm just going to put that close to the camera as well. So this is a really nice material. It's similar to the steel-based thread I just showed you. It's got steel microfibers woven in with yarn, and so it's kind of a lot softer than the steel-based thread, and it's actually much more resistive. So if you were going to have you're going to attach this these 3 different threads to a circuit. This first one would be really bright because it's just basically pure copper, super conductive. This second steel one would be a little bit duller, and then this yarn would be really dull because it's not very good for passing the current through it. It's quite resistive. But that could be like a bit annoying because you're like, oh, I want to make these bright circuits and bright lights. But actually, it's really great because it's you can kind of make sensors with that. And what I mean by that is, for example, this pom-pom. This pom-pom has kind of regular yarn and also some of this conductive yarn that I just showed you. And it's, when I squeeze it, like this, which everyone loves to squeeze pom-poms, right? It changes, it makes it, I squeeze really hard, it makes all of the little traces in there close together, and it will make the light stronger because it has kind of less resistance when you squeeze it. And that means that you can do really nice things with this material. You can kind of make all these lovely things like pom-poms or other things, and you can squeeze them or pull them or press them, and they change in resistance, and you can end up making some really nice sensors with them that sense squeeze, pull, push, and kind of different feelings, which you can hook up to a light or your computer or something else to trigger different things. So that's those different materials. Now, what I'm going to do is I have my multimeter. I'm just doing a little shout out to E-Stitches Bristol, which is a group that I'm part of, and also Wicked Fabrics. These are 2 E-Stitches or E-Textiles groups that meet regularly and share ideas and knowledge. And so this is my multimeter. I'm just going to get it out of this little case. It's the cutest multimeter ever. Let's just put this down here. Right, so what is a multimeter? Well, this is, a multimeter is used, it's a bit like a probe, I suppose, and you can use it to look at circuits with. So these little, the two probes, here and here, and you can kind of literally use them, where are we? Use them as kind of eyes to see what's going on in your circuit. So you kind of, I can't, no, lost the plot. You, so for example, I get my yarn here. This is the yarn that I just showed you. And I'm going to turn my multimeter on to the third setting. This, you see that. So there's off. Second setting is this one here, which looks at current, and then the third setting there it's got this little omega sign. You can just about see, and that measures how much resistance is in a certain material. So, and it uses ohms, which is what the omega sign stands for. Yeah, so let's just see what that means in actual real life. And it's probably going to be hard to show you and do at the same time, so you'll have to trust me that something is happening. Maybe I can try putting it a bit closer. So for example, I've got my two ends, and I'm going to put one here and one here, and I should get a reading, which I do. Oh, a reading on my multimeter, which says 300 and fit. Oh, lost it. 300. It's jumping about. I'm reading upside down. 1,000. Okay, approximately this amount of conductive yarn is 1,000 ohms. Which, if you don't know the scale, that doesn't really mean much. But so let's look at another bit of conductive material so we can kind of compare the two. So that was the yarn. Let's look at the steel, which you can hardly see on the table, but it's there. So to do the same measurement, doink and doink, and that is, ooh, hello, it's 8 ohms. So wow, there's quite a big difference there. So this one, for this amount, was about 1,000, and then this one for this amount, which you can't see because it's a black dress, is about 8 ohms. So quite a big difference between those two. And then let's just look at this lovely copper. Same distance. I know it's going to be not very much because it isn't. Oh my god, what does it say? 1. 1 ohm. So we've got 1,000, 8, and 1. So you can kind of get an idea. I mean, even though maybe that number doesn't mean anything, you do get an idea of different kind of scales of resistance in that material. And so maybe a little bit more about the multimeter. Oh, I have a comment. If we have a multimeter. Ah, yes. So there's a really good question. I have a automatic multimeter. So the reason I've got this one is because it's very cute. It's tiny. It can fit in your bag, and it's what it does is I will look at a circuit with it, doink, like I just did, and it will kind of waver around trying to work out what's going on, and it's a bit annoying sometimes because it just kind of, the numbers change and you have to sit there patiently waiting. But the nice thing about it is it just does it all for you. It's like automatic. You don't have to do any like thinking beforehand, which I like. There are other kinds of multimeters, which I don't have at home with me now, but they're called, they're more manual settings. And the way they work is you'll do the same thing. So you set your dial onto the ohms measuring resistance section, but there might be 3 options to choose from, and you're like, oh my God, what am I going to do? It says 20, 200 or 2000, for example. I can't remember what they exact say. And so what you have to do in your head before you start making the measurement is you have to kind of work out what scale you're going to be working at. So for example, what I just did with this copper, if I was using a manual multimeter, I would set it at 20 ohms because I'm like, okay, it's going to be around 0 to 20 because it's quite low resistance. So I would kind of make that measurement in my head. It's going to be in the tens, basically. And then this second one, the steel, I'm not sure. Obviously I tested it, so I know. But you might not know. You might think, oh, it could be 20, it could be 100. So maybe you would try it with the 20 and you would get the results, or you could try with the 200 setting and you might have a 0.1 or something like that, which means that you need to move down the scales to get a better reading. And then the final one, this yarn that I measured first, what did I say? It was 1,000. So you'd be like, oh man, this is going to be really resistive. I'm going to put it all the way up, crank it up to 200 because it's going to be in the hundreds zone. So you're kind of just like making that assumption before you start and putting the right dial according to what you think it will be. Yeah, hopefully that makes sense. It's difficult to explain without the actual thing here, but you can play around with that. So whilst we're here with the multimeter, as I said, I have been looking at different materials from my around the house, like thinking about what's conductive, and I've found a few things that kind of have a really low resistance. For example, coins, like literally 0 on my multimeter. That's one. What else have we got? I have this little teapot, which again has a really low resistance. So just things that are metal around the house can make, you can use and kind of with E-Textiles kind of embed them into your circuit and somehow. So these are all ones, and all you need to do is just take your multimeter and literally just put it on the ohms and just try things out to see. It's another way of looking at things and looking at the world and seeing what resistance is. Actually, this one is, yeah, it's pretty low. It's like 0.1 or something because it's quite conductive. So those are the two. That's the way to use your multimeter. That's the way I've been using it. Okay, so what I am going to do, I've had a look at some different ways of using the multimeter, and I am going to show you how to make a circuit with some of the materials that I was showing you. So I've got some fabric. This is an old sheet that I have at home that I've just kind of cut up. And what I thought I'd do first is I'm going to cut up a bit of thread. I'm just going to briefly show you how to make a stitch, because even though to some people might have this kind of maybe domestic kind of knowledge of making stitching and knitting, not everyone does. So what I found in the classes that I've taught in the past is that we must not assume that we all know how to do a stitch and how to do it. And I'm going to do it with a regular thread just because it makes it easier to see, easier to use and practice. So if you're going to practice it, I would recommend practicing stitching with a regular thread. So the way I'm starting is I've got a needle, just threaded the needle with some cotton, and I'm just going to do a running stitch down here. And the way that I start stitching is I make a small stitch in the fabric, and then I do another small stitch, okay, and a third small stitch. There we go. And so what that does is it really secures the the thread into the material, and no need for knots. It's just a really nice way of doing it. And then a running stitch is literally you put your needle in to the fabric and then you come out again like this in a straight line. That's one stitch, and then you just keep on doing that. And you can also do multiple stitches at the same time. There we go. And then there we go. So I'll just show you close up. So it's just, that's the kind of most simple stitch. And although I've done chain stitch on the circuit that I've shown you, I'm going to just carry on with running stitch because it's a lot easier. And let's just tie that off. And I tie a stitch off in exactly the same way as you would starting off. So just 3 small stitches like that. Okay, and just cut that off there. Okay, here. There we go. So there's just a really simple stitch. So let's get started, because in the process of doing this, I can show you some other tools that we use with E-Textiles. So I'm just going to cut a bit of this. Actually, I've only got one of these little embroidery hoops, so I'm going to take this off and use this one. Let's have a go. And you don't have to use an embroidery hoop, but it does make your life a lot easier if you're going to be doing stitching, kind of embroidering. I've got the sellotape on there. Whoops. Okay, so let's just cut this out. There we go. Wow. There we go. So that's our beginning surface. And what we've got in this circuit that I showed you before is we have an LED, like a light. There we go. And we're going to use some of this conductive thread. And we have a battery, and I made the battery holder with kind of DIY version, which you can just about see. The battery is kind of tucked away in there, but I'm going to use one that's kind of better for sewing into circuits for the moment, just because it's a bit quicker. And these are custom built. This is by a company called Kidtronic, but you can find these in lots of different companies sell them. Adafruit sells them. I'm trying to think of who else sells them. You can also find them in, I think Germany has a company that makes small batches of them. You can find them online quite easily. So yeah, don't worry about that. And then the nice thing is they've been designed, they've got these holes in the side, and they've been designed so that you can use a needle to just stitch them into there. It's quite easily. So that's that. And then what was the other thing I have? Oh yeah, I have the sensor, but I'm going to do that later. Okay, so at the moment I've only got 2 things, and I'm going to have a sensor at the bottom here, which I'm going to add at the end. And so when you're designing a circuit, one of the most important things to do is just sit for a moment and think about where everything's going to go. Oh, there's a message. Listening to the scissors, wasn't it? Yeah, scissors. These, okay, just a point on these scissors. These are fabric scissors, and I've got a little marker here that basically says, do not use these scissors. They are fabric scissors. You can blunt your scissors by by using them on other materials. So if you ever know anyone that uses textiles, they literally will cry and scream if you use their textile scissors with paper or anything. I've seen it happen, and it's like literally the worst thing ever. And they do make these textile scissors, because they're quite good quality, they make such an amazing sound, different to, I think, different paper scissors. I love them. So don't use scissors for paper. And yeah, so that's those. Yeah, so we've got those two things. And then the first thing to do is just think about where everything goes. You would be surprised by how many times people might make a circuit and then like build it or sew it. And it's like, oh, it's so beautiful. Yeah, great. And then they forget to put the battery in, and then it's like, oh, where does the battery go? So make sure you include the battery. And I'm just going to draw a little dot where the battery is going to go, where the LED is going to go. And then I will do a little dot where I'm going to put the sensor. 2 dots, because essentially what these spoon sensors are, and put them here, is they're just a break in the circuit. So it's just where you would normally, if you just had a circuit with a battery and LED connected, the light would be on the whole time, and these just kind of allow you to either shimmer the light using the spoons or turn it on and off. So that's what that's for. And then, what should I do first? I'm going to put the LED on first, because that's fun. Get a bit of textiles. Oh, I'm actually going to use, I'm so sensitive with my scissors, is that I'm going to use my little nail scissors to cut this conductive material with, because I just don't want it. Even this metal might blunt my scissors. So yeah, I have like a knee-jerk reaction to using those scissors. Okay, I'm going to thread my needle. You know, people say that threading the needle is the most difficult thing, and so maybe we can just look at how I do it, because I've been doing it for such a long time that it's kind of become second nature, and it's difficult to explain. But basically, this conductive thread is actually really hard to work with, because it frays. And so if you ever get into trouble and it's fraying too much at the top, like you can kind of unwind itself. You can see that it's kind of unwound and it's frayed. Don't try and thread that. Just chop it off and start again. So you might need to take a bit more. I normally take about an arm's length of fabric, because that's how much you can sew with. So just take a bit more than you need, and then you can just chop it off if you need to. And then what I do is I get a needle that has a reasonably big eye, but not too big, because it will be difficult to sew with, and then squash the thread into my fingers and like pinch it into your finger and thumb, and then here we go. Now I'm not going to be able to do it. There it is. Here we go. Okay. So, oh yeah, there's some scissor chat going on. Yeah, I would definitely keep my scissors away from in the office, away from anyone, away from housemates, whoever. Just keep them in your pockets. Don't let them out of your sight. That's the recommended way of doing it. I have a friend that wears scissors as a necklace around her neck, and she actually won't use this coloured scissors. She only uses black and white scissors, because she loves black and white. Yeah, so I've threaded the needle, and then before I start, I'm going to curl my legs of my LED. So this is an LED. Let's just get a battery. I have this little set of batteries, which I got from the Pound Shop in the UK, which I think is also known as the Dollar Store, maybe, in the US. And they have a set of 8, and it has different kinds, and some of them aren't very good. So that one hasn't got some good ones. Let's use this one, it's slightly better. Yeah, there we go. So I have a little coin cell battery, and they're pretty easy to get hold of. Let's have a look. So this is, just pop that on there. So this is my LED, that's it working. And let's talk about the LED for a second. It's got 2 legs, here we go. And one of them is longer than the other. And then your battery has 2 sides. One is positive and one is negative. And you can see it's positive because it has a little plus on it. And so I always ask people what they think about what they think, which leg might be the positive and which might be the negative of these LEDs, because it has to go one way or the other, or it won't work. It only works one way. And if you think about it, the easiest way to remember it is the long leg is bigger, and positive is plus bigger than negative. And so the long leg is going to be positive. And generally, when you ask that question, people get it right. But these legs as they stand, aren't going to be very good to sew into my circuit. So what I'm going to do is a really lovely technique using these pliers. And these pliers are designed for jewellery. So they have this really lovely kind of coned nose rather than kind of other kinds of pliers which have a flat end on here. And what you can do with the legs is you can curl them and make, just put that there, and make these cute little curled up points that you can sew, a bit like these points here on the battery. And let's just start doing that. Okay, so I'm going to go with the negative leg first, and the way that happens is you just take the end there and you just twist it and try and make it so you can see at the same time. It's really satisfying. Oops. There we go. Okay, so can you see that? Just twisted the little leg. And then I'm going to open it out to make it easy to sew so it's flat, so I can sew it flat on my piece of fabric. And that was the negative leg. And then here's a top tip. On the positive leg, if you go a bit further down and you twist, you can have one small hole and one slightly larger. And that way, there we go, you can tell what the positive and what the negative is without having to test it. Because that's one thing that does happen is you twist them and then they're like, oh, which is which? Okay, there we go. So, just show you so you can see. It's a really nice kind of tangible way to see what's positive and negative. So you can see, we know that this is the negative and this is the positive leg, and you can keep track, especially if you're doing like 100 of them and you need to sew them in. Okay, so that's going there. Let's just get my fabric. And then I'm going to do my little trick. I'm going to do my little trick of sewing one. Oops. Okay, one thing about this fabric is it can be, sorry, this thread is it can be quite knotty. My friend used to call it brambly, because it just like knots like brambles. Okay, there we go. Yeah, so you just have to do it slowly. Alright, so I've secured the fabric. There's 3 different, I'll just clear this out of the way, 3 different tiny stitches, and now I'm ready to, what should I do? Let's just see what row that this is. That's the positive, so I'm going to go positive to positive on the battery, and you can see it's the positive there. It's got a little plus sign there. So let's sew in the positive leg. Okay. All right. So maybe I'll do 2 more stitches. I'm trying to like stitch this so that it's nice and secure, because then you get a better connection in the circuit. Whoops. There we go, that's enough. I've done about 6, I reckon, 5 or 6. If you're counting, let me know. Okay, there we go. So then that's one side of the circuit is secured, and then I'm just going to do a little dot to where I'm going to sew it to, so I know. Okay, so let's do this running stitch. Oops, see, I told you it's bloody brambly. I've got more chat. Bending LED's leg in small circles. Yes, it's a good one. Some people also colour one of the legs in, like they might colour the negative leg in black, and that also works. But you know, the bending thing, you're going to bend them anyway. You don't have to get a pen or a Sharpie. It just makes sense, really. All right, here we go. So very neat. Oh, it keeps on getting stuck. You see, this is so, it's not so easy. So there we go. There's my start of my circuit. Let's get this battery in. And I'm going to do the same thing with the battery that I did just now with the LED one. Just secure it. And let these batteries fit. Yep, the right one. There we go. Right. And if you want to at any point kind of test that it's working, your multimeter comes into play at this moment. So you can use another function on the multimeter just to test before you cut the thread. You might want to test it first, and then you don't have to like fiddle around and start again. So on this particular multimeter, if you go to the same function that I went to just now, which is the Amiga sign for ONS, there are some different symbols. And what I do is you select, we want to have the symbol that looks like a Wi-Fi signal up here. So let's select. And you can't really see it very well, but there's a little Wi-Fi signal here, which is kind of just, it signifies sound, I think. And what that is a continuity tester. And it just tests to see if there's a connection between 2 points in a circuit. So for example, I'm going to put one part of the probe here, where I've sewn to, and one part here. And you can hear that it's saying, yep, there's a connection. So I'm like, okay, I've done okay. I can cut the wire now and start on the next part of the circuit. Okay, so I'm just going to do a couple of stitches in there and not make a massive tangled mess. Haha. Anyone who's used this, I'm just going to tie it off in a knot because it's too messy. Anyone who's used this thread will know that it really does get knotty. So it's like you're, you know, it's good for some reasons and bad for others, but we still use it. Okay, now let's just get another bit and just carry on. So one thing about the multimeter, and I'll put some links in the video, is there's some really nice versions of the kind of concept of continuity checker, multimeter by some different E-Textiles artists. For example, Hannah Perner-Wilson, who's part of a collective called Cobacant, has made an on-hook multimeter, and that is where it's using a crochet hook to measure the resistance as you're crocheting. So you can make your circuits with this crochet hook, and then it will tell you what your resistance is so that you can kind of test the circuit as you're making it, which I think is really nice. Okay, just tie this off. And you know, while I'm talking about this kind of DIY tools, There's another artist called Irene Posh, who I will put a link to her work in, and she's done a project is all about tooling and thinking about the kind of tools that are different, or the kind of intersection of tools from textiles and electronics that E-Textiles use, because you're there's two kind of knowledge bases you're using. One of them is kind of rich and diverse history of textiles and the tools and knowledge that come with that. And then there's also this kind of technical tools like the multimeter, or the kind of conductive materials, and the kind of rich history and knowledge of that. And when they come together, they make a whole new set of tools. And so she's been exploring the kinds of tools that you might use or want when textiles and electronics intersect. One of the tools that she's designed was a kind of pin cushion, where you can use a pin cushion as a multimeter. I really want one of those. She's also been developing some different, using kind of safety pins and kind of actual dressmakers pins as ways to kind of probe circuits, because these probes on the multimeter aren't always designed for this kind of work. So they work. You can actually literally put a pin into your fabric and test the conductivity of it. There we go. So nearly there. All right. I'll just tie this off. Oh yeah, I should test it. I didn't test the last one. Whoops. Getting carried away. Okay. So just sit like that. Now I'm going to test it now, which I probably should have done on the way as I was doing it, but never mind. So yeah, great, and yeah, great. Okay, so I have a working circuit. Let's pop a battery in there. And then let's just use something. I'm going to use this coin now to just put it across. Yay! It works. Oh, it's too dark. There we go. You can see. So I'm using this coin as a sensor there. There we go. Okay. So I'll show you how maybe you could embed that in a second. So that's the kind of basic layout of a kind of really basic circuit, and at the moment it's just in this hoop. It's a bit abstract, but you can imagine how you could kind of embed that in different contexts, in kind of clothing, or in different, doesn't even have to be in clothing, it could be you know, you can use, lots of people using paper with the same kind of concepts, but with kind of sticky tape, that you can actually feel the circuits on the copper tape, or kind of, some people have made these kind of use these materials to make speakers, and you're literally kind of listening to the vibrations of the fabric through that. So I will show you now a couple of sensors that I made around the house using just found materials. One of them was obviously the coins, which you can kind of see there. I've got the spoons. I've shown you the spoons. What else? Other things. These are really nice. So we call these, what do we call these? Butterfly clips. In the US they have another name, but I can't remember. But the reason they're called butterfly clips is because they actually look like a butterfly. I think they're called binder clips maybe in the US, but you get them in different sizes, and these really small ones are really cute. And again, there we go. So you can kind of use these to complete a circuit, and you can just do something quite fun. You know, maybe you have a few of them, or maybe they're connecting in different ways. Just stuff that you have around the house. What other things have I got? Oh yeah, more coins. So I found a massive jar of coins, and then I also found, probably you have this bag of coppers, which maybe you have, and I just thought it was quite fun to use the bag of coppers as a sensor. And the way that I was doing this was, just move these out of the way, was to you stick one coin onto the end of the crocodile clip. So these are, if you've not seen them before, sorry, I just brought those out and assumed people knew what they were. These are crocodile clips. I think they are called alligator clips in the US, which is, you know, but they've called them for obvious reasons. They look like a crocodile. And actually, this is another thing that people have been iterating on in terms of textile tools, because this kind of bite of the crocodile is actually really bad for fabrics. It kind of, especially if you have some beautiful silks, it really could damage it. So this is where kind of the pin techniques of using as a probe. So instead of having this kind of nasty clip, you could just pin into the fabric, and it's a much nicer join. Or you can get some really nice smooth clips. I think you can only actually get them in the US, and they're copper based and they don't have this horrible bite to them. But for the moment, I'm going to use them because that's what I have at home right now. So I have one end of my circuit into a penny, and then there's a little hole in the bottom of this bag of coins, and I'm going to stick the other, here we go, I'm going to stick that onto a couple of coins and stick that in the bottom, and then put that onto my circuit. Okay, so let's see if you can see this, my bag of coins is my sensor, and if I'm like scrunching the coins up, the light flashes, yes. So yeah, that's another thing. It's quite fun. I was speaking to some friends yesterday, and they were saying spoons would be a fun thing, or aluminium foil, which most people have. You could play around with that. It's kind of what you might have. Oh, here's something else. Oh, let's use this first. So these are great. These things. These are coins with holes in them. Just show them up. Here we go. Coins with holes in them. Amazing. We don't have these coins in England or the UK, so that's quite exciting. And these are a combination, I think, of Chinese and Norwegian coins. And yeah, they all have that. I don't know why they have holes in them, but it's amazing. And so again, I've got my crocodile clip attached to my circuit, and the other side onto the coins. And again, you can kind of see the light flipping. If I stand in the way of light, you can see it more. And so if I move the coins around, you can kind of see, and look how nice they move. They move in such a wonderful way because I've kind of tied them together with a yarn. So just like, I'm sure you could do some really fun things with that. Oh, someone just said in the comment, it's Japanese yen. Okay, I'm sorry, I didn't know where they came from. I found them just in a random drawer in our house. So yeah, so that's another thing that you can do, and I just love the way that moves. And I can imagine just like kind of wearing that around your neck or as a bracelet. It'd be really fun. And then finally, another thing which is quite messy, but you know, I just thought let's go with this. Look, I just found a random pile of keys and yarn in the bottom of a drawer. It's actually in a drawer in a cupboard. And I was like, okay, let's make that into a sensor. Really going for how messy things are right now for everyone and what's going on. So here we go. I'm going to just attach this crocodile clips randomly to 2 keys in this bundle of yarn and mess. And then let's see what happens. Oh, will it work? No, it was working. There we go. So occasionally all those keys might join, and then they create this kind of messy sensor. And you can just imagine, there we go, they're kind of joining. So they're not joining directly to each other, they're joining through this kind of tanglement of keys. And just imagine how playful you can be with different materials that you find. So yeah, there's some different custom home sensors. And what else should I do? Maybe, yeah, let's try the pom-pom. See if this works. I haven't used this for a while, so maybe it works. So put this pom-pom on here, and then squeeze the pom-pom. Yay, lights gets brighter when you squeeze it really hard, and it actually works really nicely as a stress ball. So yes. Oh, in the chat someone says everything is plastic. Oh no, maybe you have to go outside of the office. Kitchen is a really great place. Kitchen, and then like that drawer that just has random stuff in it. I feel like everyone must have one of those random drawers. Oh, I didn't try the teapot. Quickly, let's do the teapot because that's really fun. So this is I don't know if you have these. This is like a teapot that, it's a teapot, it's kind of quite meta. It's a teapot that has tea in it, and then this goes inside your cup, and then it like infuses the tea inside the teapot, but it's not a teapot, it's actually in your cup. So it's quite fun. And so yeah, I've made a little switch with this. So I'm going to put one end onto the handle of the teapot, and then the other end on the lid. And I realised that it kind of had this long bit of wire, or these beads, don't really work. So I've kind of bypassed them, and I'm just putting the crocodile clip on the lid. And then hopefully that works. Yay, we have a teapot switch. I have no idea what that is useful for or anything, but it's just fun thing that I had in my kitchen drawer. There we go. So you could kind of have that on permanently, or you could just be like, no, I'm going to use my switch, turn it off. There we go. So those are all the different things that I have around the house. I realised that it's already been almost an hour of me talking, so I don't know if anyone has any questions. I didn't get through like half of the things that I wanted to talk about today, but maybe if you have questions you could let us know, and I can answer them, or like I have like a whole pile of materials on my kitchen table that I can kind of show, and maybe they're relevant. Yeah, so just let us know in the chat. And then, is there anything else that I want to do? Oh yeah, I was going to show you some things about the Arduino. So I won't go into too much detail about that, but what I will do is show you what an Arduino looks like and how you would connect it to the circuit. And what even an Arduino is. Let's just grab one here. So I have these things here. So let's move my circuit to the side. Move over analog, come in digital. So these are different, two different Arduinos, and they're Arduino. This is a kind of official Arduino. This one is an older one. It's called the Arduino Uno, and these have been around, I think, maybe like years. 15 years, I'm not sure. They've been around for a while, but I still think they're the most brilliant prototyping tool ever, and I love using them. And so basically what I would do with this Arduino, or this one, which is a clone of the original, and I normally get these for my classes because they cost $7.99, and they work really well. And the other thing about them is that with an official Arduino, you have this kind of writing. I'll talk a little bit about that in a second. You have this writing on the side of the headers, and this clone is kind of the only one I could find that also has the writing on the side of the headers. So for teaching, or for like not putting pins in the wrong hole, it's brilliant. So what I would do theoretically, and this may be a little bit abstract, but I would have my sensor, wherever my sensor's gone. Let's find a sensor, my pom-pom, and I would have my pom-pom attached like I just had it, but instead of having it attached to the circuit so that the light turns on and off in my circuit here, like this when I squeeze, I would put my Arduino there, not actually there, but I would replace this circuit, and I would use some wires to get the information from how I'm squeezing this, or the kind of, the information into the Arduino, and then that sends that information to a computer, and then there's a whole world of possibility you can do. So your computer could play a fun song when you squeeze this, or it could kind of maybe play a really relaxing song because you're obviously really stressed out because you need to squeeze the pom-pom and it kind of calm you down. Maybe you could do some breathing meditations or something like that. And so I won't go into a lot of detail about that because I realise time is running out, but essentially all of these kind of analog sensors and circuits that I've been doing can be used with an Arduino, and the idea of that is just this wonderful possibility for sensing the physical world and kind of bringing that information into the computer. So it's just a world waiting to be explored. Now, I have some questions. Oh, there's loads of questions. Hang on. Would love to see what you've done. Oh, okay, so someone says would love to see projects you have done. So I haven't got lots of my projects here, but I do have one thing which I grab here. Move aside sockets. So a couple of years ago, I love experimenting with kind of messy things, as you can see. And a couple of years ago, I was experimenting with darning or fixing, mending with some of these conductive materials. So I was using this, which is the conductive yarn, to mend socks. And then using those kind of mended sensors as ways to kind of get information, play music, turn lights on and off, all sorts of things. And so I have one here, and this, just say this book. These books are wonderful. I'll put a link in those. It's the E-Textiles Swatch Exchange, and it's lots of different swatches that different artists making E-Textiles have kind of, they make a swatch. Everyone makes, for example, there's 30 people, everyone will make 30 swatches and then exchange them as a way to kind of exchange these very physical material knowledges in a way that's tangible. And so here we go. Here is one of the examples of the sock sensors, and this one is kind of coming here. It shows you kind of how the sensor works here, and then it's attached into here with a magnet, so I can actually take it out. And so this is, I obviously have got, when I made this up, I managed to get my favourite sparkly sock, which has terrible holes in the bottom, and then I've made these sensors, and so when you're wearing these socks, you can kind of pass in that information into an Arduino or something like that, and then trigger things with a computer. So that's one thing that I've made. But you can also check, I'll put my website in the comments, and you can check that out as well. Any more questions? The inspiration, well, maybe that's inspiration. I guess I have to go back. Oh, that would be nice. I would love to come back. Nato says, I was thinking it'd be nice to make terminals for alligator keeping leftover pins. Yes, that would be great to use leftover pins. And I'll put a link to Irene's work because she's got some really nice 3D printed components that literally could... okay, I think I'm going to leave it there. If there are no more questions, and just say thank you everyone for your comments. It was really fun. I was so nervous, but actually it was great, and it's really nice to have everyone in my kitchen, and hopefully we can do this again. So I'm gonna log out now. So thank you.